Welcome everyone. I guess we'll get started with the next session. I'm thrilled to have everybody here and to engage with what I have been waiting for all sort of season and weeks leading up to now. And that's this discussion, Future Directions in Life Science, Innovations, Blind Spots, and Opportunities. And I just want to start by saying the impetus of this sort of topic was born out of a lot of work that I've done and I've seen others sort of develop over the years around these emerging biotechnologies that people are taking up, folks are taking up using various metaphors in computation and in making. And with these innovations come a lot of questions about how we might leverage them to improve society, how the risks they might create for particular populations, and then the opportunities we might have to sort of look to the future and avoid mistakes that we've seen happen with other technologies, particularly when it comes to K through 12 education, and in my mind, when it comes to public
executive director, it was to align the mission and the operational model with a post-COVID kind of work set of ways of working. We had a whole list of uncertainties, things that we weren't going to be able to know the answers of, and the two that really stuck out to us were how large of an appetite for what we do is going to persist as we move through COVID and then into a post-COVID world, and would schools be open or online or some hybrid of the both? So what we've done is offered some new ways of working, which are remote, including online programming that emphasizes biodesign to bring people together, and working on a project like the students had indicated was very meaningful to them as we work in bio and biodesign. We also have data analysis tools that Adam Santone, who's doing the chat, was key in developing for us using our Studio Cloud. So we've learned a lot. We're trying a lot of new things, and I'd be, I don't want to take time away from others who get to introduce themselves in their programs, but we think that there is still an appetite for what we do, and we do think there are ways to adapt what we've done to all kinds of learning models, whether they're in person, online, or some hybrid. Justice, I will close my opening comments there, and happy to readdress the questions that come up after this.
That's great, Natalie. I think we have a lot to learn from you and the work you've done from the ground up over the last almost decade. I think it is developing the foundation, especially in these emerging fields, and especially in teacher professional development. And so thanks for that introduction. Now I'm going to move along to Bryan Brown. Thanks for joining us, Bryan. So it's really the same question. I hope you'd sort of introduce yourself and then maybe talk a little bit about your work at Stanford and beyond, and sort of the rationale behind what sort of drives you to do it.
Well, thank you. It's a pleasure to be here talking with this group. And so, again, my name is Bryan Brown. I'm a professor of science education at Stanford, and I've studied one issue really most profoundly, which is how does the language and identity connections for students impact who you are as a student? So you imagine yourself in that bio class, and there's 100 people there, and the teacher just bombards you with a barrage of complicated terminology. For some people, it's no problem, but for another set of people, it's a clear indication that I'm not supposed to be a part of this community. And so what we work on in our lab is studying ways to give students access to feel empowered to be a part of the science community. I want you to think of it this way. If we can cue psychological a sense of not belonging, then we should be able to do the alternative. And so if my message says to you that you're not a part of this community, then the question is, what do we do in our instruction, with our technology design, that says to students, you are a part of this community? So for about the past 17 years, we've been engaged in research, both in teaching practices and building software And the good news is that we've made great gains in opening access to students. And so my message to everyone in this community is that there's a cultural bridge readily available to you, and that's technology. You giving a lecture means one thing, but having a student of color and whether it's digital or in person, representation sends a message of belonging. Having underrepresented groups as a part of your leadership teams is important. I want to share quickly before I close a study that was conducted by Maltese and Thai, and it basically said that by the 6th grade, students have either decided to be a scientist or decided they're going to opt out. And so part of what has to happen is we have to create a generation of people who understand and understand deeply that we can send messages of access for every group. And the best way to do that is to make sure as we're teaching science, we're building generations of science teachers, whether that be at the university level or the K-12 level, but we produce people who are like-minded, who go out and change the field. So thank you for having me. I'm looking forward to talking more about the relationship between learning, how we teach, and how we promote the next generation of STEM leaders.
That's fantastic, Bryan. Thank you. I know that in your book, you highlight a lot of these same ideas in developing culturally relevant frameworks and educational models for students. And so I wonder what the implications of something like this is for these paradigm shifting science curricula that emphasize design and computation in life science. And so as we move on, I want to welcome our third panelist, Mike Tissenbaum. Mike, thank you for joining us here. I just want to let everyone know that Mike has a very different perspective
to code, right? And what we found is this another big issue for a lot of students, against particularly those underrepresented in these fields. Black youth, Latinx, women, particularly women of color. And part of that reason is because a lot of research has shown that it doesn't connect to their lives or communities in meaningful ways, right? And that they don't see how going down these pathways can help improve their lives or those of the people they care about. So while I was at MIT, working with App Inventor, which is a block-based programming language for building apps, we were like, well, how can we change the focus of what computing education is all about? And so I developed this theory around computing education, moving from computational thinking to what we call computational action, which is really less focused on kids learning to code, but actually developing solutions to problems in their lives or communities that are personally relevant and meaningful. And in doing so, that they develop their, what we call computational identity, right? Which is that they see themselves, of course, why wouldn't a phone ring? Sorry. Their computational identity, which is the idea that they feel themselves to be part of this broader community of people who create and build with computing. And it can even be, in some ways, doesn't have to fit the stereotypical or traditional notions of what the computing identity is, because that's often exclusionary and is set within certain paradigms that may not fit for them. So letting them define it, but feeling that they're part of it. And the other part is this idea of digital empowerment. Not just that they have this identity, but that they can put that in meaningful ways. And so when we do this, you know, we've had a lot of opportunities for kids to build really exciting things. But in the process of doing this, there's been a couple issues. And we see it, you know, in CS a lot. And it's sort of my call to caution for the biology, you know, world and biohacking world. And one of them is that if we have kids doing linear projects, right, that they're doing things all towards the same end, and they don't have that agency to create and build or design solutions, we're going to get a generation of kids who can build a thing, but only if it's well defined for them, not being creative explorers, right? And sort of innovators and defining what it is they can do. The middle picture shows that there's like a lot of new technologies coming out, and that's great. But then if we want it to be about kids driving the innovation, how do we design materials or activities that allow them to start to understand what's possible with them, right? Not just these cookie cutter approaches, but, you know, go forward. The other challenge with that, though, is as we scaffold kids to be creators, there's this thing that Paulo Blickstein talks about, which is the curse of the keychain, which is when he taught kids how to build keychains with the 3D printers, that's all they ever did. They couldn't really break out of that first thing they're taught. How do we give them agency to explore beyond the tutorials? So we want them to get started, we want them to create, but we want them to move beyond. A challenge with that, though, right, is that then how do we get teachers or instructors or facilitators to feel comfortable to allow these things to happen or have the skills to support them, right? So in the top right corner, what we see is we work very hard at building scaffolding materials to help them through the design process, thinking, as everybody knows, when you give kids the chance to build anything, they build everything. And so how do we bring it in? And the last part is the kid in the bottom corner who was in one of our projects. How do we get them to take ownership of the knowledge within the communities, the classrooms, the after-school programs, so that they can help their peers? So this is one of those solutions. This is one of those opportunities, build a knowledge community where they all get to, instead of just looking to us as the experts, they look to each other. And that actually has really powerful opportunities for the kids to see themselves as mentors, building that sense of identity, building that sense of empowerment, and making them feel that they're authentically part of it and can keep going forward. All right, I'll stop there with my 30 seconds to go.
Thanks, Mike. And thanks to all of you for that fantastic, really outstanding introduction behind your work. Now I want to sort of think about one of the earlier points I made about sort of synthetic biology. It alone, in my view, is an example of this shift in life science to sort of democratize access to the field. We see that in the development of low-cost portable wet lab devices, the development of curriculum, like as exampled with a lot of the work Immunolabs and BioBuilder is doing. And we also see it in the development of community lab spaces, which are very similar to what we saw in the 90s with computer clubhouses. And so the shift is meant in many ways to support broader access, democratize access, and engagement. And yet we understand there might be potential risks that emerge. And so I wonder, and maybe we could start with you, Natalie, since you're there on the ground, what sort of risks are you seeing emerge? And then what sort of opportunities do we have as a field to sort of overcome them as we think about diversity, equity, and inclusion, and the whole point of DIY and community lab biology?
Well, the greatest opportunity we have, the greatest source of inspiration we have, the greatest, I think, source of wisdom we have is actually in the students that we teach. I think that they invariably surprise, delight us, inspire us, come up with ideas and ways of putting the world together that we haven't thought of, and that they bring a freshness and a wisdom to it that is that gives me great confidence and hope that they're going to be great. They're going to knock it out of the park. I am sure of it. But there are sort of headwinds that we face as we try to democratize science and empower younger students to be creative, to take the reins of design and not self-limit and believe that they have to, pass through so many gates before they can possibly have any authority to imagine in a good way. So I think that the headwinds that we have faced within BioBuilder, when I present BioBuilder to communities, to teachers, to superintendents, to sort of groups of people who haven't really thought maybe about bringing engineering and science together in the world of design and allowing students to sort of be bioimagineers, right? The things that I find are, we don't understand this. So oftentimes people will say, I don't really get it. They will say, this is too hard for us. We find that superintendents, people who run science curricula district level will say, that's a fine program for maybe advanced students, but do you have something simply that what you're doing is too hard? So they sort of underestimate the capacity within their systems. And then the third one that we've faced often, and actually one that we aren't sure quite how to address, and maybe it's not for us to address, is that we don't like it, right? So there are certainly, it's not to be ignored. There is a significant fraction of people we talk to that say, I don't like you mussing around with the DNA in our cells. So, you know, I don't understand it. It's too hard for us, and I don't like it, are the headwinds that we find. But I think when they hear from students who have done this and hear from teachers who have, you know, integrated this into their worlds and their teaching, many of those can get put aside. So that's my boots on the ground perspective on that really important question.
That's great. And so, so sort of to mix it up a bit, I wanted to see what Mike, your thoughts were about this. And so, coming from a CS and sort of electronic sort of perspective, what do you think are opportunities that we should think about in a movement, an educational movement designed to disrupt and democratize and open access for learning? I mean, in many ways, computing was meant for that, right? Seymour Papert talked a little bit about the cost of computing and the personalized computer and what that would mean for education. And yet we see that the one computer per child ended up being hugely problematic because people were still left out of really meaningful learning. And so what do you think about that? Are there opportunities that we might be able to leverage to sort of seize this moment?
Yeah, and I think, you know, there's a couple things that I think are really important. And, you know, I say this coming from the computer, you know, education space as well, is I think don't rush to make this a thing that fits all, because the thing that fits all often misses the people at the edge of the bell curve, right? And so it, you know, and it often privileges those people who fit very comfortably into that middle space, right? And so you see it in the CS education that's going on right now, this rush to do coding at the expense of all else, the rush to do teaching kids to program without the sort of culturally responsive pedagogy, the connecting to their lives. And we're seeing a lot of kids dropping out because it's having the same issues that physics and math had, you know, that Maltese and Thai and many others have talked about, because they see it as not being something for them. And so when we're designing this, I think it's really important that for long-term success, you want to look at the small, careful steps of designing curriculum, the careful steps of implementation and assessing what's working, right? So we had this big thing where also the assessments have always been, you know, the computational thinking became very popular, right? And so all the tests are, can kids do loops? Can kids do functions, right? Can kids describe decomposition, right? Not whether these kids actually wanted to do any of this, right? Do they see it as something that they want to pursue? Can they critically solve a problem with it, right? You know, you mentioned Papert. One of Papert's biggest things was that he said that students, in the pursuit of solving problems, challenges would arise. And in the process of solving those problems, they would learn by overcoming or not overcoming those challenges, right? And that's how a lot of us do things in CS in the real world. It's not that we have a list of instructions that we go through. We go to Stack Overflow, we do all these things and we learn, and yet that's not how we teach, right? And so we need to think about it in the biology community under a similar lens, right? It's not enough just to teach people, and you're going to have to excuse me because I'm probably the least expert in the domain field, but you know, how to pipette and all of these other things, or how to sequence genes or whatever it is. And to what end? It's like, no, just learn this. It's don't worry, it'll be good for you later, right? And so we need to find ways of connecting to kids' lived lives. Because it really is. And I think the biology space really does connect, right? There are so many ways to make it meaningful, to see your world. What I like to say is my goal is to get all the students who leave the kinds of programs I design as seeing the world now as a possibility spaces, right? Ways of looking to address opportunities and challenges in the world around them. If we do that, even if they don't become biomakers, right? They're going to have the fluency to talk to the people about that. If they're designers, managers, you know, a whole host of skills that are connected and deeply, you know, associated, but, you know, surrounding biomaking, then that's going to position them to be successful for their life, right? Rather than just, you know, it's the same issue I say, we don't need 3 million programmers, right? That's not what we need in CS. What we need are people who can think, create, build, and work with programmers to envision a better future for everybody. So.
That's great. I think you raised, it's a natural segue, I think, to Bryan Brown, who I view as an expert in some of this, well, certainly based on the book, Science in the City, that I read. That is this idea of developing learning experiences that are relevant, right? Culturally relevant, thinking about Linda Darling-Hammond and her framework, relevant to their interests, thinking about Christopher Enben over at Teachers College and some of his work. What do you say, Bryan, as the sort of the West Coast expert on the subject as it relates to science?
Well, I'll start by saying you know everything you need to know about learning from your own experience. So let me say, there was a time when we all remember phone numbers, right? And I could say, hey, what's Justice's phone number? And then you could rattle off a number. And so I'm going to argue, and I don't know you, there's people on this call, I'm going to argue that all 55 of us deleted that information the moment we could scroll down our cell phone, which is something very powerful about the cognitive behavior, how our brains work. We have these incredible computers on our shoulders, and they delete all unnecessary information. So the moment you didn't need that number, right, you deleted it. Now, what numbers do you remember? And I would argue, and again, I don't know you, I'm just assuming you remember your home phone number, the one that was your emergency number. If you missed the bus, what was mom or dad's, maybe a sibling, outside of that small circle of necessity? I'm going to argue you forgot it. And so one of the things that tells you is there's a difference between acquisition and learning. And acquisition is, if I'm engaged in important work, I will learn the things that I need to learn along the way. And so there's one of my favorite Saturday Night Live skits. It's too genius. They're saying it's a telenovela for introductory Spanish, and all they're saying is "Donde está el baño?" You know, it's like all of the basic and most necessary phrases in Spanish, because that's all you remembered unless you use it. And so here's my point. I'm going a long way to get to this point. The knowledge that we use most regularly is what we will retain. And as a result, we can't engage in this parallel play where we don't speak across the disciplines. So as educators, we've been saying for 20 years, don't worry about the content. Teach the kids what they want to know, right? And so in the case of every biological phenomena, the way we ended up learning about it is we were trying to solve a problem. But then when we teach it, we take the problems out of the instruction. And so teaching them about biodegradable materials should be about, how do we clean up the trash in our yard, right? How do we get rid of it? How do we compost at home? There's all the biocurriculum you need right there. And what it does is it empowers them to be expert. You tell me what 14 or 15-year-old, after learning about this, doesn't go home and say, you know, Grandma, let me explain this to you. You know, that's why we remember, because it is important, necessary information. So my point is that when we teach, the curriculum is always the people in the room. So we've got to find, well, what is the CS that is in their lives that they would know, that learning to code would provide an answer. So if that's, I'm going to make a robot and that robot is going to help us clean the floors, then that gives us the context in which we teach some basic coding languages, right? We do the engineering, we build the code. So here the message is that we need to reach across the aisle, learn from other disciplines, and teach in context, because that's the way our minds work anyway. It empowers kids to learn, but most importantly, it gives them a skill set. Once they can do it and they can explain the world, you don't have to ask them whether or not they consider themselves a biologist. They've been doing the work of biologists, and that's the most empowering thing you can do.
I think that's outstanding, and just another great segue into really the pinnacle question for us all. I mean, at the Bio Summit, we have a large population. I would argue the majority of us probably identify as educators in some way, right? Which is why I think the track has grown so much. And so I wonder, so it's a mix of scientists, a lot of educators, and community activists and organizers, I would say. That's what makes this part of which makes this community special. And so I wonder what you would say, each of you, to educators and community movers, if you want, about how to sort of create meaningful learning environments to students. And so I'm talking about the practical, real world, useful implementations. And so I don't know, Bryan, do you want to start, since it sort of builds on some of what you were talking about already?
Sure. So when we train our teachers, we ask them to always start with a pre-assessment. And a pre-assessment is just a set of questions about a topic, so we get a sense of where their interests might lie. And so if I'm thinking about bioengineering, I might start by saying, you know, what are the things you want to fix in your community, in your household, that have to do with biological phenomena? And that's where your curriculum is rooted. There's if you're interested in the research, there's years of research in this field. It's kind of disappeared a little bit, but it's called co-generative dialogues. And that research says we have to start by recognizing the relationship between the student's interest, and then it's now the professor or the teacher's job to figure out how to teach science in the context of where their interest lies. And so I would strongly recommend starting in that place.
That's great. Natalie, I want to pose a question to you, given your work. I recently read a project you did with a professional development implementation. And so I wonder if you could answer the same question, but from the perspective of professional development, teacher learners.
Yeah, I have found that teachers are such eager learners and are such joyful learners. It is a delight to teach teachers. And if you, if we as, organizations can offer teachers truly professional development, treat them as the professionals that they are, offer them, ways of perhaps implementing things in the way they see fit in their classrooms. They are the experts of their classroom domain. I think that a big disconnect that can happen within teacher professional development is when content experts sort of assume that they know how a teacher might need to implement this into their classrooms. There is not one size fits all. Classrooms are so very different from one another. The thing that unites them, though, I think, is the desire that teachers have to see their students succeed. And I think there is a growing appreciation among teachers that, their situation, their environment, that is actually perhaps their greatest creative advantage, right? You do draw interest from your local environment. We are all part of the biology living world. We all have things that we experience through biology. And I think that we can use teachers as agents of change and bring that creativity and that sort of love of learning, joy of curiosity, and satisfaction from problem solving into teaching sort of across platforms. I don't think it's something that can only be done at high level, advanced sciences. I think it really can be done across the board.
That's great. Mike, are we missing anything?
No, I will say I really like what Bryan talked about. I've often talked about it as sort of human-centered design. I get students into that process of recognizing, they might have something that they already have in mind, but we often will sometimes work with them to recognize things in their community and go through the process of talking to stakeholders in their community, right? Family members, community leaders, approaches like that get them into thinking in that way. And for me, that's a huge step, because that's what makes it authentic for them, because they're also going through the process, and it also gives them an added set of skills. Again, for me, it's this idea that we want to instill in them their ability to be problem solvers. And so going through understanding some of the steps of doing that, of connecting with the community, not just designing at, but designing with and designing for is a big step in this, because I think that also connects. The other piece I'll add, and I'm sure this is pretty, for everybody else, is that a big part of it at the end is that you need to build in an opportunity for them to showcase it back to the stakeholders, right? There's nothing worse than designing something and then it's like, cool, you're done. We're going to go put that on the shelf and it's going to fade off into nowhere. So it needs to be for an authentic audience. And then that audience needs a chance. They need to present it so that they feel that authenticity of their work. Like, oh, I'm doing the work of real biomakers or computer designers or whatever you want to say. And here's where everybody's giving me that feedback. And, you know, the last piece that I think is also important is adding in that reflection for them of what would they do if they had more time? What do they want to do next? Again, exciting in them that potential of continuing, that this is not a one-off, but it's an iterative process and it's a continuum, right? They're just starting on this journey to be creators and makers. So.
Yeah, I really appreciate that idea of like creating moments for reflection and that iterative process of sort of that we see in inquiry style models of learning and even design, where you're going sort of back and forth thinking about what you've done and constructing or building knowledge, if you want, around it. And so one of the things that sort of comes across in all of your answers is this idea of putting, and I think you said it, Mike, moving from thinking to action, right? And I'm doing a project with some of the community labs in this community where we're looking at how people are using these modern day, if you want, biomaker spaces. And what occurred to me is that a lot of them are shaped like apprenticeships, right? And so I wonder what your thoughts are about how we might empower students to teach, carry out science, design with biology in a very authentic and sort of apprenticeship way. How do we get them in the lab pursuing a question that they're into? And then how do we support them along that journey? And so I'll open this one up. I won't identify anyone, but whoever wants to sort of go first. How do we support an apprenticeship model in learning in these areas?
Do you mind if I jump in? Does anybody? So a couple of things I've done in a lot of the work I do is that I, you know, even before they get into, say, the apprenticeship, is I bring in other people who are doing those jobs in the field. But I often also strive really hard to make sure that they're representative of the population I'm working with. Like, it doesn't help if you're working with a bunch of Black and Latinx youth and you bring in a bunch of white guys to explain to them how this job works, right? So the slide I showed was a river, and it was, it's actually the river that runs past the school, and that was the thing they solved for. And so we brought in people from MIT's water biology research lab, and we actively worked with them, brought in women and students of color to present their work. So all these kids are like, oh, wow, what I'm doing is just like them, and I see myself as them, but a couple years behind, right? The work we're doing similarly here, we're working with several nonprofit groups that work with at-risk Black youth, young men and women. And we've got a partnership with the engineering department. And we're actually working with, you know, undergraduate Black engineers, both men and women, and bringing them in to be the mentors with the kids. So again, it's this, oh, I see where my work goes and I can become the people who are working with me. I see a pathway and I see myself in them to motivate them to do that. So for me, it's also that they see the work that they're doing in our after school programs, in our camps, as being part of that trajectory of mentorship. It's not just a one-off, it is the first few steps of doing that apprenticeship. They're working with these people and doing the work that is authentic to what they would do if they kept going down this pathway. So.
Great. Anyone else? How do we support apprenticeship models for learning or empower?
I would say that it's literally how we train our teachers here in our Stanford School of Education, our science teacher education program. Because there's a difference between, as I mentioned before, acquisition and learning. And we want to create acquisition opportunities. And the way I like to think about it is to say, you know, one of the things that carpenters are phenomenal at is measurement, right? Because the task of building the chair, the task of designing and making sure the door works requires precision. And so you don't have to teach the math, right? You just need to build the opportunity where the math is embedded. And so you should engage in bioengineering the exact same way. And so the way to do that is to make sure that the science that they're learning empowers them to make sense of the world, and then they have to do something with that. So for example, in our summer camps, we teach kids about the relationship between food health, diabetes, and dialysis centers, right? And so it's just a lesson about food chains. But the assessments, the way that we measure how they know is to have them write a letter or record a PSA. And that communication, that the end product, which is to explain how the scientific phenomena is impacting your world, is the thing that empowers them to see themselves as a change agent. But they learn the content and in the process of engaging in the action of trying to engage and change in the community that they're in. Now, that does a couple things. One, it is the most efficient means of learning by acquisition. Second, you can't convince a kid that they're not going to be a biologist, that they're not a part of the biology community, when the science that they're learning is literally being used to speak about biological issues locally. And so it's the way we train our teachers here. And so I would argue that that should be a framework for how you approach camps and instruction. Is we learn scientific phenomena, but we're going to do something meaningful beyond ourselves. And it creates a great, healthy pressure for the kids to go out and do things that are valuable and impacting their community.
That's great. Natalie, do you have any thoughts? Or I'm sure you do, but did you want to share anything?
I'll be brief. I know there are so many topics to talk about. I think apprenticeships are incredibly important models for giving students that sense of self as scientists, sense of self as engineer. The see one, do one, teach one model works really well. You have to let people make mistakes. I think that's a part of the apprenticeship model that also works so well, is to, demystify, really just pull back the curtain on what does this really look like, right? It's not that perfect, everything works exactly the same every day. It just doesn't. And so I think that connection with the reality of it is exactly what people need to see and start to know that is a place that they can succeed, even if they're not, that they don't have to be perfect at it in order to succeed at something. And so all's been said. I agree 150%.
That's wonderful. So I guess, and a final sort of question, and also an opportunity for you to share sort of final remarks on this panel. There's the chat is just exploding with opinions about different things and the challenges with apprenticeship models. And all I see is just eager educators really who really care and want to make a difference, but they realize that on the ground it's a challenge. And so if you were to sum up your view on what the ultimate purpose of a good life science education is, how would you characterize that as you fold it into your final remark here? And I'm gonna go in this order: Mike, Bryan, and then Natalie.
So I guess for me, the goal would be a good life science biology program is one that has students coming out of it as seeing themselves as capable of using that to better their lives and that of their community, right? And the excitement of their own potential to do that. And so, I guess that goes back to kind of what I said at the beginning. Far too often, a lot of these, educational spaces are driving facts in the kids decoupled from what they're going to do with it, right? And so they often come out and like, okay, I'm never going to use this in my life, right? So why would I continue to learn, or why would I bother to engage? And so it's a lot like what Bryan said. For me, it's this idea that they come out with, again, this eye of potential for what they want to do now that they see themselves as capable of doing it. And then the excitement. So what that can do too is feed in for them is they want to learn more because they want to apply. They find new problems and they're like, oh, well, how do I solve this? Okay, well, now I have to start learning this and this to start filling in all the pieces. And if they come out of their like early, middle or high school life sciences with that excitement, then you can start saying, okay, to do that, now we have to get into the weeds and you need to learn some of that deeper technical rather than shoving that in first because you're getting that excitement and they know they're learning those things to create and continue and build and affect change to those who matter. And so, you know, get the excitement first, get the identity, get the empowerment first, and then they'll be excited to learn all the nitty gritty down the line.
Great. Bryan?
I forgot the question. I was so engrossed with Mike's response, but I do want to add that you hit the nail on the head when talking about this idea of really empowering students to know more than facts. I don't know why I'm stuck on this cell phone thing, but I'll go back to the cell phone thing, right? It's not impressive that people know anything anymore. You can Google anything. So having facts or information is relative, right? It's I shouldn't say it's relative. I'm not going to go there. It is less impressive, and it's not as important as a skill as it once was. The argument is that we need to be able to discern why we know things, why alternative ideas cannot therefore be true. So the skills that we use to understand biological phenomenon, to understand algorithms and computer science have never been more important. So I don't want to see a generation of people who know coding language or a generation of people who know biological facts. I need them to have rich scientific knowledge, how to apply scientific knowledge to making sense of phenomena, to also be empowered to make sense of the world they're living in. If you ever wanted to see a time where that was important, go outside and talk to someone about antibodies right now, right? We are in a science education crisis because the focus on facts hasn't done well. And so I will tip my hat to the people who wrote the new generation science standards because they saw it coming. So the idea was, let's shift from a value of ideas only to a value of skills that are transcendent. I can teach and understand ideas, and I can go make sense of the world around me. That includes design. And I think that is what I'd like to see moving forward, is that we really build a community of people rich with scientific reasoning and skill sets that empower them to go out and impact the world.
Guess you get the final word, Natalie.
I'm glad because I get to repeat and just say thank you to the other panelists to say, yes, we need people who are capable and have confidence in their capabilities, people who can ask good questions and can listen to feedback and refine their questions, people who can reason and look at the world and say, that does make sense, and no, that doesn't make sense, is very, very important. And then the application of the skills to build a better world is vital. I'll add one more thing that I would love to see, and I would view as a measure of success in our future, would be that if we can all look at success and our work as not operating with a sense of scarcity, but of plenty, that there are so many good ideas out there, that there are so many great people to work on them. We are not trying to cut one another down and try to be first to the finish line or anything like that. We actually really need to listen and know that there are great ideas in the world and lots of them, and we should be supporting lots and lots of the future innovators and you know, they have great wisdom, and there's a lot of important stuff to do. So I'd love to see support for more of it.
Thanks so much to you all. I don't know of a better way of ending other than to say important goals of education are, you know, as an ode to all of you, have both occupational importance, but probably a more civic one for everyone. And one that sort of has an asset orientation about how we might interact with and produce in the field. And so thank you for your collective time. This was an incredible opportunity for me as fans of you all. And so thank you.